All right, good morning. Going to go ahead and do 4.5 right now. Basically, what we're going to start looking at is the inverse trigonometric function. So just like the other operations we've been looking at, these have operations that will basically do the opposite of them or undo them. And so just as a reminder, when we have a right triangle like such. If this is our angle theta, there's our right angle. If we call this x, call this side y, call this side r, then we can define everything. Cosine of theta is going to be the adjacent side over the hypotenuse, so x over r. The sine of theta is going to be the opposite side y over the hypotenuse r. Tangent of theta is technically sine over cosine, which makes it opposite over adjacent, and so it's y over x. The hypotenuse would cancel. Secant of theta is the reciprocal of cosine, so it's going to be r over x. Cosecant of theta is the reciprocal of sine of theta, so it's r over y. And then cotangent is the reciprocal of tangent, so it's going to be x over y. And in the case of our unit circle, we had all these where r was equal to 1, and so cosine would be just x, and so for example, like on the unit circle, r would be 1, so we'd end up with x over 1, which would just be x for unit circle here in red. Okay, and so this is true the whole way down. Just make the r's equal to 1, and that's it. So we're wanting to basically find values where we already know what the sine or cosine or whatever equals. And so I'm going to make this a theta here real quick. And so when you go through, we'll actually be able to figure out what they are. So if we look at this one, it's telling us the sine of theta is square root of 2 over 2. And so if we look at our unit circle, we basically have 4 places, the 45-degree ones. So I'm going to draw them in like this. On the 45-degree ones, their coordinates are square root of 2 over 2, square root of 2 over 2. And so this is square root of 2 over 2, square root of 2 over 2. And this one's square root of 2 over 2, square root of 2 over 2. And this one's, that's negative square root of 2 over 2, square root of 2 over 2. This is negative square root of 2 over 2, negative square root of 2 over 2. This one is square root of 2 over 2, negative square root of 2 over 2. And so when we look at this, you notice it's asking us, when is the sine of theta square root of 2 over 2? Well, this is going to be true whenever the y coordinate, because you look over here at sine, right? On the unit circle, it's y over 1, and so it equals y. And so what we're looking for is we're looking for basically when does theta equal, for what angle, what angle gives us that? When does y equal square root of 2 over 2? All right, when does that happen? And if we look, it happens right here. It's square root of 2 over 2. Over here, it's square root of 2 over 2. Down at the bottom here, when we look at this one down there, this is negative square root of 2 over 2, and this is negative square root of 2. So because they're negative, they are not going to be part of our answers. But here, our two answers are going to be at this angle here, and then this angle here. And so the first angle is going to be pi over 4. That's that first little angle in there, this little one right there. And then the larger angle is going to be 3 pi over 4. Okay? And so our answer that we got here is an angle. And I even changed it on over to theta. Okay? So basically, what we're going to do is come up with our operation that's going to do this for us. But that's the general idea of what we want. So let's first start looking at the inverse sine function. We'll have inverse for cosine and everything like that. But we need a function that's going to actually, so cosine, you give it an angle and it tells you the ratio of the sides and stuff there. What we need is something that we can give it the ratio and it tells us what angle it goes along with. So it undoes the cosine. So here we have inverse sine function. Recall that a function f has an inverse function if it's 1-to-1 and passes the horizontal line test. You'll notice that the sine function will not pass the horizontal line test, because if you draw a horizontal line, it's going to run right through a bunch of it. So what we do to combat that is we have to restrict ourselves so we don't get repeated answers. We're going to restrict the domain of what we're allowed to plug in so that it will work. So what we're essentially going to only worry about is from here to here, because if we start going back down, we fail the horizontal line test. If we start going too far this way, we immediately fail the horizontal line test. So we're basically going to go just through half of a cycle there and get this done. If we then take and look at that line shape we have, it's over here, same line right here. And if we take and reflect it along the y equals x line, which is what we do for inverse functions, that's if we have the original function graph, we reflect it across the y equals x graph, and we get this curve right there, which is going to be the inverse graph of it, and kind of restricts us there. So what happens is, over here, if you'll notice, for the regular sine function, when we restricted ourselves, we restricted our domain from negative pi over 2 inclusive to pi over 2 so that we didn't repeat anything. And then our range was from -1 to 1. Well, now when we go over to our inverse function, we're going to have the opposite of that. And our inverse function here, we're going to call it arc sine. Sometimes you hear it called inverse sine, sometimes you hear it otherwise. It is written, and you'll see it on your computer, on your calculators and stuff, like this. Okay? And so it'll be an arc sine with that little -1. Now be careful, that -1, I see a lot of students make the mistake of thinking that means 1 over sine, because when it comes to numbers, if you put a negative exponent, it means a reciprocal. Well, here it doesn't mean reciprocal, it means inverse function. And the same thing with a regular number. It's not saying it's a reciprocal so much as it just happens to be that. It's saying that it's the inverse of multiplying by it, so that would be the reciprocal. So this is not equal to 1 over sine. Please do not make that mistake. That's the important thing. Those are not the same. This is not sine to the -1 power. It's arc sine or inverse sine, but most commonly called arc sine. And so since it's the inverse function here, what's going to happen is our domain and range are going to flip-flop from sine. That means our domain will be -1 to 1, and our range will be -pi over 2 to pi over 2, which you can see from the graph. If we see right here, we're coming down to -pi over 2 and up to pi over 2. We're looking at the red line now. Maybe I should erase the green one here. We're looking at that red line. And then we're going from -1 up to 1. And we stay always within there. And so that's our domain and that's our range. Okay? So basically, make sure that you are realizing that we have done this. And in fact, that's what your calculator would do. If you use this on your calculator, it's going to restrict you to these domains and ranges. And so here we have some find the exact values of y. So here we've got y equals the arc sine of square root of 3 over 2. And so what we can do is remember that we're looking for values from that are basically on this side of the unit circle here, because we've restricted ourselves between -pi over 2 and pi over 2. And if we look at that, we need to find all the values that have signs or y values as square root of 3 over 2's. And if we look, we know that if you look at your unit circle, if you sketch it out, you'll find that this is the point 1/2 and square root of 3 over 2. That's at an angle of pi over 3. That's pi over 3. And so there we have a square root of 3 over 2 in that position. If you look at do it dottedly. If you look at the pi over 6 point right here, it's square root of 3 over 2 and then 1/2. And that's not going to work because the square root of 3 over 2 is in the x part, and we need it to be in the y part. Not because this is a y, that was just kind of chosen to be nice, but because it's sine or arc sine, so we're looking at y values. And then if we come down here, negative pi over 3, we would find this coordinate would be 1/2 and then negative square root of 3 over 2. And that's not going to be correct either because it's negative. So all said and done, we only have one place where we get a value of square root of 3 over 2 for that. And so therefore our arc sine of square root of 3 over 2 is going to equal pi over 3. Okay? And then if we take a look over here at the next one, we see we want the arc sine of negative 1/2. So again, what we're interested in is finding values again on this side of the unit circle because that's where we restricted ourselves to and for arc sines. And when we take a look, we've got really just one location that has a negative 1/2. So remember over here, we've got a pi over 3 is going to have square root of 3 over 2 and then 1/2, except we need negative 1/2, so that one's out. And then the only other place over here is at negative pi over 6. I think I said pi over 3 a second ago. Negative pi over 6 is going to be square root of 3 over 2, negative 1/2. And so there we go. There's our negative 1/2 in the y position. It's within this side of the unit circle where we're looking. And so we can say then that the arc sine of negative 1/2 is negative pi over 6. Okay, between negative pi over 2 and pi over 2. The last thing here is the arc sine of 3. Now, if you try to do this one, especially if you type in your calculator, you're going to get an error because remember, for our range, we're not allowed to have values outside of negative pi over 2. So, I'm sorry, that's for our range. For our domain, I'm saying range, for our domain, we're inputting, we're not allowed to have values outside of negative 1 to 1 because there is, no, if you take the sine of something, it's always going to be between negative 1 and 1. And so if we say, hey, what angle, when we take the sine of it, gives us 3, which is what this one is saying, well, there's nothing. We can't actually get a 3 out of sine, so you cannot do the arc sine of anything that's greater than 1 or less than negative 1. So this one's undefined, all right, because it's outside of our domain. All right, let's take a look now at the next one, the inverse cosine. Very similar to inverse sine, except this time we're looking at this little area here to prevent our repeating. So that's from 0 to pi. Again, half a circle, so or half of a period, half of a cycle. So our domain here for sine is 0 to pi, and our range is again negative 1 to 1. Right? We're going from 0 to pi, and we're from negative 1 to 1. That's where we're staying in. So that's our domain and range for the cosine function. And again, we can take here along this dotted line y equals x, and we can take our original function here in blue, which is our cosine, and we can mirror image it across that line. Boy, I didn't draw that very well. Across that line and get right there to get our inverse function. And there it is right there. And you'll notice that it goes from negative 1 to 1 for our domain, which is what the range of cosine was. Because remember, whenever we do the inverse function, they just flip-flop. And the range goes from 0 to pi up there. So 0 to pi. So we just flip-flopped the domain and range and got it going there. So that means that basically when we look at the unit circle for this one, we're going to stay on the top half of it to be between 0 and pi, right? This would be a 0 angle, this would be a pi angle, and that's where we're staying. So for here, let's take a look at, let's find the arc sine of square root of 2 over 2. So if we draw the top half of our unit circle, right? Then we are going to get two places that have square roots of 2 over 2's in them. That's square root of 2 over 2, square root of 2 over 2. And then over here we have negative square root of 2 over 2, square root of 2 over 2. And if we look at this first one, this right here, we're looking at cosines, we're looking at x values, that's a square root of 2 over 2. This one over here is negative, so that's not what we're looking for. So what we can say is that the arc sine of square root of 2 over 2 is going to be equal to this angle here, which you should know by this point for square root of 2 over 2 is pi over 4. And there's our answer, pi over 4. And again, remember, we restricted that so that we couldn't have it. What I'm going to do is leave this one for you to try, get you started on it. Remember, you're looking only in the top half of the unit circle, and then you're going to have to find an x-coordinate that has negative 1/2 as the x-coordinate and find what angle that would be at. All right, I'll leave that for you to try, and I'll go back and write it into the notes when I'm done here. The inverse tangent function now. Now we can undo tangents. So tangents, if we stay between negative pi over 2 and pi over 2, they don't repeat. If we go outside it, they start to repeat, and then you fail the horizontal line test. So we're staying inside negative pi over 2 to pi over 2. So for tangent of theta, we're going to restrict our domain, and we're not going to include but be between negative pi over 2 and pi over 2. We never actually get to those values, so it's not inclusive of those. And then we're going to go for a range here a little different. We can actually go all the way down to negative infinity and all the way up to positive infinity. So it's negative infinity to positive infinity there. And then when we come over and, again, we mirror image it across this y equals x line, and we end up flipping this one that's there in blue, and we get this red one right there, or pink one. And that flip-flops our domain and range. So the domain is the range of tangent, so negative infinity to positive infinity. We have no restrictions on what we can put in for tangent like we did for sine and cosine, where we had that one where we were outside a negative 1 to 1, and it gave us an undefined for that sine one. Same thing for cosine. And then that gives us our range, which is the domain of tangent, as negative pi over 2 to pi over 2. And so you'll notice then that's going to restrict us to the right side, just like with sine. It's going to restrict us to the right side of the unit circle there. Okay, so we have to stay in there, negative pi over 2 to pi over 2. Okay, and so here, let's try some. Let's find the exact value of y, and here is y equals the arctangent of 0. So again, we're going to take a look here at this side of our unit circle, and if we look at that, remember tangent is y over x, right? Remember, this is essentially telling us we're doing the arctangent of y over x, which means in order for that to be 0, we're doing the arctangent of 0 over x. See that? So really what we're looking for is when is y equal to 0 in this case. And so if we look at that, that's going to end up being this coordinate right here. The coordinate there is 1, 0. If we look up here, it's 0, 1. And down here, it's 0, negative 1. And so the one that has 0 for y is right there. This one's our answer, which means the arctangent of 0 is equal to 0. All right? And again, I'm going to go ahead and leave that next one for you to try, and I'll write it back in a minute when I'm finished with the video so you can look it up in the notes. Okay? The reciprocal inverse trigonometric function, so y equals cosecant of 2. Now, be careful again, arc cosecant like this does not equal 1 over the arc sine. Okay, don't do something like that. It's not just a reciprocal like the others. So let's take a look at this. What we can say is the cosecant of y equals 2, and therefore the 1 over the sine of y equals 2. Okay, and then sine of y equals 1/2, which means y equals the arc sine of 1/2. Okay, so if you notice this, this is what we end up happening. So what that tells us then, going over to here, what this tells us is if we look at this, we've got the, I think I kept saying 2, but let's make that a z, just so it's true for really anything. It's a z. And then so what we've got here is the cosecant, the arc cosecant of 2 has to equal the arc sine of 1/2. You see that? It gave us the reciprocal. Up here we started with cosecant of y equals z. We ended up with arc sine of 1 over z equals y. And so what we can then do is just do the arc sine of 1/2. Again, sine restricts us to that right-hand side, and 1/2 occurs at square root of 3 over 2 1/2, and that's at pi over 6. All right, like I said, you really got to know your unit circle if you didn't know it already. So that's at pi over 6, and there's our answer. Okay, so just remember that what you're doing is basically saying that the cosecant, arc cosecant of x is equal to the arc sine of 1 over x, that kind of thing. Okay, this is what you're interested in doing. So now let's take a look at arc cotangent. Here we have the arc cotangent of 2.8. And so if we take a look at that, we're going to have cotangent of y is equal to 2.8. And then we're going to have 1 over tangent of y equals 2.8, which means tangent of y equals 1 over 2.8, which means the arctangent is 1 over 2.8. Okay, and so just like before, what that means is when we're doing arc cotangent of 2.8, it's going to equal the arctangent, similar to above, of 1 over 2.8. All right, and this one you'd have to put into your calculators because, you know, I don't know that one off the top of my head for a unit circle, but you should get about 3.4 or 0.343 radians. Make sure your calculator is in radians for that. Okay. Next one, let's try arcsecant. Now we don't need to go quite as crazy as we have been showing it all out, because like you can probably guess, arcsecant is going to be the arc cosine of 1 over 25, which should give you about 1.53 radians. Okay. Next, we're going to do composition of trigonometric and inverse trigonometric functions, and I think I might do that in, no, it's only just, we only have just this and then the next page. So let's go ahead and take a look at this. This is what happens when we do basically have them undo each other. So as long as you're between, as long as your x value here is between negative pi over 2 and pi over 2, then the arc sine is just going to undo the sine. And as long as you're between 0 and pi for x as your value in there, it's just going to undo it. And as long as you're between negative pi over 2 and pi over 2, arctangent's going to undo tangent, because they're inverses of each other. If you're outside of these values, then, or outside of these domains, then it's just not going to quite work, because it's going to give you something else, and we'll kind of get to that in a little bit. But right now, if you're inside those, it just undoes it. Here, sine undoes arc sine if x is between negative 1 and 1. For this one, cosine undoes arc cosine, just gives you the x if x is between negative 1 and 1. And then here, tangent undoes arctangent if you're between negative infinity and positive infinity. So it just always will undo it. All right, so take a look at that. So let's take a look at this one. We've got find the arc sine of the sine of negative pi over 8. And so the first thing you ask yourself is negative pi over 8 between negative pi over 2 and pi over 2? And the answer is yes. It is greater, you know, negative pi over 2 is going to be less than negative pi over 8, and negative pi over 8 is going to be less than pi over 2. So it is in between them. Therefore, they just cancel. and you get arc sine of the sine of negative pi over 8 equals negative pi over 8. And they just cancel, okay? Take a look here at the arc cosine of the cosine of 5 pi over 4. Now, for arc cosine, we need to be between 0 and pi, but we are not. So it's not between 0 and pi, okay? So it's not in there. I don't need those parentheses. Not between those, okay? And therefore, if we take a look at this, this is what your calculator would do if you type this into your calculator. Remember, we're only supposed to be, for arc cosines, we're only supposed to be on this top half, right? That's what keeps us in that range of 0 to pi. Well, we're not. We're over here at 5 pi over 4, right? Remember, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. We're over here at 5 pi over 4. And when we're there, we look at our numbers, and it's going to be negative square root of 2 over 2 and negative square root of 2 over 2. So if you're doing the arc cosine of that, what it's going to do is it's going to actually assume that it's going to give you a value that's inside of there. And so what's going to happen is it's actually going to jump you back up to here. And even though you have this 5 pi over 4, when you take the cosine of 5 pi over 4, what it's going to do is it's going to give you this value right here. Except if you look up here, this is negative square root of 2 over 2, square root of 2 over 2. Your calculator, and by convention to make these things, is only going to look in this pink range. And it's going to look in this pink range for where do I have negative square root of 2 over 2 as my x value, and that's right here. And so this is the angle, pi over 4, 2 pi over 4, 3 pi over 4. And so the cosine, basically what happens is the cosine of 5 pi over 4 gives you negative square root of 2 over 2. That was this value down here. But then the arc cosine, all it ever sees is the negative square root of 2 over 2. It doesn't see the 5 pi over 4 ever. It's hidden from it. So what it does is assumes that it's in this range here, the top half, and it gives you back the angle in that top half that also has negative square root of 2 over 2 as its answer, and that's 3 pi over 4. So watch that a few times. It's almost like if we had a machine that took a bicycle and broke it apart, right? That's our, we had some bike or something here, some handlebars, and we threw the bike into this machine and it broke it into its parts, which was just, some wheels and, and some other little bars and stuff like that. And we threw those into then another machine, so this breaks bikes apart, and this one makes wheelbarrows, right? It's gonna make a wheelbarrow. I don't have room to write that. And so it's gonna pump out, something that's a little different. It's still made of a lot of the same parts, but it's gonna assume that the parts you gave it were for a wheelbarrow because it never knew that it was a bike ahead of time. I don't know if that helps or not, but that's the best I can come up with here. Because basically this cosine in here hides the 5 pi over 4. And all the arc cosine ever sees is the negative square root of 2 over 2 that the cosine of 5 pi over 4 produces. And so it pushes it back into that spot. Okay? So last page, let's take a look here at finding the rotation angle of a security camera. So this is how this can be useful. If we take a look at this, a security camera is to be installed 20 feet away from the center of a jewelry counter. The counter is 30 feet long, so that's this 30 feet here. Oops, I'm going to do this in a different color. That's 30 feet long here. That's a 30 feet. What angle? Oh, and it's 20 feet away here. What angle to the nearest degree should the camera rotate through so that it scans the entire counter. So if we look at this, what we can do is actually draw a right triangle in here. We can draw it right here, here, and here. And then we'll take that right triangle and we'll look at it over here, and we've got 15 feet here. That's half of the 30 feet across here. We have 20 feet right here. That's how far the security camera is away. This is our angle, and then this here, we're gonna call it, now over here, it's called theta. The whole angle is called theta right there. So I don't want to call it theta, so maybe I'll call it, I don't know, we'll call it phi or something like that, used for angles quite often. And so basically what I want to know is what angle produces that. And so if I look at this, I know the two sides. I know the side opposite and the side adjacent to it, which means that's what goes along with tangent. Tangent is opposite over adjacent. So I'm going to go with tan of phi is going to equal, and I picked it because these are the parts I have, is going to equal 15 feet over 20 feet. And my feet will cancel, and I'll have 15 over 20, which is just 3/4. And then now I want to solve for theta. So I'm going to do the arctangent of the tangent, or not theta, phi. I'm going to do the arctangent of the tangent and the arctangent of 3/4, because what you do to one side, you have to do the other. On this side, it's going to cancel out, and we're going to get the arctangent of 3/4, which if I type it in here, we have, oh, let me make sure I'm in radians. Yep, I'm in radians. So we'll go home and I'll do the arctangent of 3 divided by 4, and that's going to give me about 0.64350111088. You don't want to round until you get to the end. And remember phi, if you look at phi over here, this is our phi, this little angle in here, it's only this angle right here. But we need the whole angle all the way across, which means it's phi there again, which means theta equals 2 times phi, our little half of the angle, which means it's 2 times that 0.643 whatever, which gives us 1.287002218. And then now we're at the end, and we're supposed to round to the nearest degree, which would be about, we have 1.27, we're not all the way in, this is in radians, and I need to convert it to degrees. So to convert the 1.287002218, keep that stored in your calculator, radians to degrees, I have to multiply by pi radians in the denominator and 180 degrees in the numerator. And so if I do that, if I divide it by pi and multiply it by 180, I should get 73.7397, not, I think 7397 9529. Sorry, I lost my place. Which then rounds off to the nearest degree to be 74 degrees. All right, and so there you go. Hopefully this makes a little more sense to you. Go back, rewind it, watch it again, and then I'll be available for questions for you in the next class. Or if you have any questions, just shoot me an email. All right, talk to y'all later.